Good evening, everyone. Welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Hi, I'm Scott Sorrell, going to be your host here today. And today we're coming to you from Bergamo, Italy, where we have a real science symposia titled Redefining Amino Acid Impact. New Research Unveiled. All right, and I've got an esteemed bunch of guests here. We got to my right, Dr. Mike Van Amburgh. He's from Cornell University. We've got Dr. Usman Arshad. He's from the Federal Institute of Technology in Zurich. Mike, I should have said that you actually gave two presentations at the symposium today. One more technical, one more practical. The first one was titled Amino Acid Nutrition for Increasing Milk and Components. The second was more applied, and it was titled Feeding Cows for 1-ton Components and 20,000 kgs of milk. Dr. Arshad's presentation was titled Lysine, a vital amino acid for maximizing milk production. Then Dr. Stefano Vandani from Balchem came on the stage, and he gave a presentation called Driving Milk Component Yield with AminoSure. So we'll be digging into all those. Also want to make sure that we acknowledge our co-hosts. We got Mario Paradini. He's from Agravit, one of our good customers here in Italy. So welcome, Mario. Mario,
thank you.
Real quick, these three folks have already been introduced today. So why don't you go ahead and introduce yourself?
Yeah, I'm the technical manager in charge for Agravit, which is an Italian premix and complementary feed producer. And it's been a long time for us to distribute the Balchem portfolio. So it's a pleasure to be here with you today.
Yeah, welcome.
Thank you.
Glad you could join us. Dr. Sean Richards, introduce yourself, sir.
Good evening, everyone. My name's Sean Richards. I'm the Rumen Technical Services Manager for Balchem for Europe, Middle East and Africa, and come from a farming background, and I've spent close to 30 years in the ruminant nutrition field. So great to be with you.
All right, great. So just to remind everybody, this is a pub theme, and in keeping with that, I've ordered the table a nice wine. It's called Moscato di Scanzo, and it's a local Moscato specific to the Bergamo region. As the story goes, Mike, the priests would serve this at Mass. And so, you know, you and I have known each other for quite a while, and either one of us are priests. So
means we're blessed.
it feels a little
We're blessed.
sacrilegious.
We're blessed.
So as the story goes, this was originally served as white wine. But the priests wanted it red, right, for the ceremony, for the Mass, to signify the blood of Christ. So what they did was then put 5% of the red Moscato in there, and so that it's red, and it's a nice color red. So anyway, so that's the story. Anyway, so before we get started, folks, here's to an interesting pubcast.
Cheers.
Cheers.
All right.
Awesome.
Cheers.
Cheers.
Cheers. It's sweet.
At Balchem Animal Nutrition and Health, we strive every day to deliver results you can see in your animal's productivity and your bottom line. From a smooth transition into the milking string for your fresh cows, to a happy welcome home from your furry friend. From a strong start in your poultry flock, to consistent weight gains for your finishing hogs. We expect to earn your business and your trust with our people, our products, and our science. Our people have an intense passion for your animals and your success. You can count on us for honest, candid advice and practical solutions for your toughest challenges. As the global leader in choline production, chelation, and encapsulation technology, we take our obligation to you and to the environment seriously. Our products are backed by the most extensive and thorough research portfolio, while our business is committed to advancing environmental sustainability and animal welfare. In the end, it all comes down to results. Balchem delivers real results you can count on, results that exceed your expectations, and results that bring true value to your bottom line. Leading the charge to meet the nutritional needs of ruminants, monogastrics, and companion animals, Balchem offers a growing portfolio of nutritional products and a dedication to innovation and industry sustainability. Balchem is here to solve today and shape tomorrow.
All right, Mike, to get us started, let's start off with your first presentation. And that, again, was titled Amino Acid Nutrition for Increasing Milk and Components. Would you, if you will, kind of give us a thesis of that first presentation and what were some of the key takeaways?
Sure, Scott. I think the major take-home there is that, for years when we talked about amino acids, we really we basically directed it towards milk protein. Right, and I think what we've realized is that amino acids in a high-producing lactating cow have many uses, not all going to net requirements, and that we have to understand that if we're going to meet their requirements, especially with these modern Holsteins that produce a lot of milk, and that we're finding as we meet those requirements, all of a sudden they're expressing things like milk fat and doing other things that we didn't imagine they could possibly do. Right, so it all of a sudden taught us that, hey, amino acids are intimately involved in things like milk fat synthesis. So a lot of learning going on. That was really the take home.
So one of the notes I have taken is that you talked a lot about nitrogen efficiency and nitrogen excretion. And can you talk a little bit about the role of nitrogen and its impact on the environment and humans?
Sure. If we look, if you look across Europe, the United States, New York has decided that they want less nitrogen excretion now. Which is why we're busy trying to figure this out. And we look at Ireland, we can look at the Po Valley of Italy, we can look at the Netherlands. All of those countries are saying, hey, we have too much fugitive nitrogen. And when we look at agriculture, we're responsible for about 81% of that. So it's on us to figure out how to reduce that. Dairy cows are part of the solution. And we've got to figure out how to make more precise diets, right? If they're excreting 250 grams of urinary nitrogen a day, but we could get them down to 150 or 160 and still remain highly productive, that's a lot of nitrogen that we didn't buy, that we didn't feed. We've got alternatives now to be more precise, bring in amino acids, bring in some carbohydrates, and make the cow more efficient, right? So that's it's really that desire to reduce that environmental impact, but at the same time find the financial benefit to the dairy industry.
Yeah. Tanya, any questions out there yet?
Here at the front,
Tanya, up front.
Front in the orange, here.
No, up here.
No, penso che serva il microfono, Claudio.
We spoke about amino acids and my compliments for your presentations. But what is difficult for me to understand is to quantify the real amount of methionine and lysine in the fodders that we use in our rations. We're very precise vis-a-vis the bioavailability, but how precise are we then in calculating the availability of these amino acids within the ration? Are there any indications on this? How can we do this? How can we, solve this issue?
For the presentation, the question is about quantifying and how the forage content in amino acids will influence the overall amino acid balancing, and what are the best tools to quantify the amino acid content of forages.
Yep, that's what I thought he asked. That's good. My Italian's okay. So the what was that? Okay. So I'm going to speak from my perspective. We have more work to do, but at this point, all that when I show you those diets and when I show you those formulations and the cow responses, for the most part, all of those amino acid values are coming from reference library in the CNCPS. And we have some updates to make because we've upgraded our methods for amino acids. But the forage amino acids that we have in the CNCPS are actually pretty robust and pretty useful, right? So if you're using NDS, you can be pretty comfortable that those amino acid values are as good as they're going to be for right now. Again, we will be updating those, but when we update the forage amino acids, we'll update all the amino acids, which includes the tissue and the milk and the microbes, right? And that's coming, but we're okay the way we are because everything that I showed you is with the present version of the model, right?
If I can just add to that, I absolutely agree with you, Mike, that the CNCPS library is very robust. Stefano in his presentation showed a comparison of different diets based on different forage types and showing very, very similar, if not identical, limiting amino acids. And I showed the same at a similar presentation in the UK, using different forages. Actually, the numbers don't change that much depending on the forage type. I think also it's important to point out, a lot of forage protein is rumen degradable protein, and that becomes microbial protein. And the microbial protein, I know there will be some updates, but the microbial protein is a relatively fixed and relatively agreed upon profile within the scientific literature. So actually, the amino acid profile of the forage has an impact, but it's relatively small. I think it is important also to be correct on the amino acid profile of your other protein sources in the diet, your soya, your rapeseed meal, your sunflower, whatever else you're using. But that is where the robust library of CNCPS is very, very important.
Can I add one more thing?
Please go ahead.
I think it's also important to recognize, that was good, Sean. I think it's important to recognize that, forages, feeds, alfalfa, corn silage, sorghum, whatever forage we're talking about, the only time that we would expect those amino acid values to change would be if we have heat damage during the fermentation. But then that's a separate calculation that we know how to make now, right? If it's ADIN, if that ADIN function goes up, now we've taken out those available amino acids, right? Or if you've had other very wet forages and there was leachate or something like that, now maybe we've got some variation. But it's not that there's not any noise in the process there. But for the most part, all those amino acids are highly conserved in all of these forages, in the microbes, in the tissue, right? They don't change. It's just some of the management around the forage that might get us in trouble.
Yeah, if I can add from the research point of view, we do research in Switzerland, and Switzerland has a very good quality forages, and whatsoever experiment we design, we have to feed like 70% forage-based diet. So recently we conducted an experiment where we wanted to test several amino acids, including rumen-protected histidine as well. It's not commercially available, but we were able to get from someone in China. So when we analyzed the diet from the amino acid perspective, those cows, although they were producing 32, 33 kilos of milk, but the amino acid profile based upon the forage diet was deficient. So when we added those amino acids, it was much beneficial. So the cows produced 2.5 kilos more milk after adding that, even though the forage was excellent quality. So I would agree with Sean that depending upon the forage quality, the amino acid profile might not differ a lot. So, yeah.
Mike, kind of a follow-up question to that. You had presented some data, some actually provocative data on requirements, and for a cow producing or consuming 71 to 72 megacals, the methionine requirement would be 85 grams per day, histidine 85 grams per day, and lysine 229 grams per day. So to be able to get that much amino acids in there, can you tell me where's it going to come from? What percent forage, grain, microbial protein? looking at it.
Yeah, yeah. Anybody else want that question? No, I'm just
It's yours.
You know, forever and always, we're going to want 45 to 50% of that to come from microbes, right? That's our cheapest source. That's our best source. We want the highest rumen efficiency. We want to maximize, there's where we want to use a maximization, right? We want to maximize the amount of bacteria and protozoa, coming out of the rumen. And right now, we talk about this, we're only talking about the bacteria, but we know we have the protozoa. They actually have a higher amino acid and higher lysine content than the bacteria. So anything we can do to enhance protozoal function moving forward, and that'll be in the next version of the model, that's going to help us meet that requirement, right? So that means having more sugar in the diet is going to help those protozoa grow and be more effective. From that, Scott, it's figuring out how to put the right protein sources in play. We have the luxury in the U.S. of being able to use porcine blood, right? Not ruminant, porcine blood. But that gives us a leg up on the methionine or on the lysine and the histidine. When we move out of that ability, now we have to do better with protecting plant sources and being able to feed enough of those and having a mix of them to be able to meet those requirements. It's going to be more of a challenge. And in reality, the only way we're going to do that effectively is to have rumen-protected sources, right? We're just going to have to get to the point, I said this the other day, where we've got them priced accordingly, and everybody's feeding more of it because that's what these cows are telling us they need.
All right, very well.
If I can just comment, great answer to a very difficult question there, Mike, but, it is about maximizing that microbial protein. And, Mike is right, you've got to then balance it with rumen-protected amino acids. One of the opportunities there is to reduce your protein and replace that crude protein with additional energy. And that additional energy will obviously drive or potentially drive increased microbial protein. So it's that balance, and that is one of the real opportunities about reducing crude protein, balancing with rumen-protected amino acids, allowing you to feed more rumen energy, potentially more carbohydrate that gives you more microbial protein. And therefore, that's how you optimize efficiency, both in terms of nitrogen efficiency, but also feed efficiency. And that's really critical.
Yep. And we're going to have to learn to get comfortable with those lower nitrogen or crude protein values, right?
Absolutely. We've got to get comfortable with crude protein levels coming down from, I come from the UK, where the traditional UK diet is 18.5% crude protein. We've got to start to become comfortable with numbers moving below 15 and even towards 14% crude protein and maintaining good rumen nitrogen levels, which is where the CNCPS model gives an advantage in being able to measure those rumen nitrogen levels, rumen ammonia levels, to make sure you maintain rumen function.
Yeah, well said. Any more questions out here? We got one up here in front.
Thank you for the very wonderful and informative presentation by Mike, Usman, and Stefan. My first question is that we are feeding like choline, ions, 12 grams pre and post calving in transition period, and we are managing and balancing amino acid at the same time. When we are balancing amino acids, do we still need 12 grams of choline ions that both act as a methyl donor? Or the potential capacity the potential capacity of as a methyl donor of choline is much more than methionine products. And just adding to it that, as we heard yesterday, that the farmer is feeding choline throughout the lactation. Is it worth it or recorded research that if we feed more than 21 days in milk, we will get some benefit out of it in terms of reproduction, production, and health benefits?
Yeah, I mean, I think there are like 5 or 6 questions. So I would start with a very short answer first. So if you are asking that if we can replace methionine with choline or choline with methionine, I would disagree with that. I think, yes, they are both methyl donors, but if you see the roles in the body, choline has quite some lipotropic role. So I think there is substantial evidence which suggests now that choline is able to remove triacyl glycerol from the liver and reduce the incidence of fatty liver. And fatty liver is obviously associated with the reduced productive performance. So I think choline is very much necessary during the transition period because that's the time when cow is mobilizing lots of body tissue because she has to support her milk production and the dry matter intake is not increasing as it should be, so it's a gradual intake. So to support the fatty acid export from the liver, I think choline has an essential role. Now, if you ask me, does methionine also act as a lipotropic agent? We have some studies in vitro which suggest that it does, but if you ask me realistically, there are, I don't know, 12 or 13 experiments which were done just to test if methionine would be able to reduce the incidence of fatty liver. And none of those experiments, if I remember correctly from my PhD literature review, none of them actually showed that methionine reduces triglyceride levels in liver. So with that, if the numbers are the correct and the literature, I think there is no replacement of choline with methionine and methionine with choline. The other question which you asked is, what should be the optimum duration of choline supplementation? Should it be just during the transition period, or should it be all the way throughout the lactation? So short answer is, we have done a meta-analysis with 21 experiments where people feed choline just during the transition period, 21 days before, 21 days after calving. And cows not only produce 2.5 kilograms more milk, but when the supplementation was stopped after transition period, they kept producing milk for next 25 to 40 weeks in lactation. So if you're just wondering about the effects of choline on the milk production, yes, if you feed in the transition period, it will have carryover effect to support in the later lactation, because cows who are producing more milk in the early lactation, they are pretty much possibility they're going to take the same peak and enter into the mid-lactation. But if you ask me if supplementing extra choline beyond transition period would have some additional benefits on production performance, I'm not sure on production performance, but I can certainly say that there is very cool data coming up which suggests that it improves the health and the repro in the dairy cows. So in the meta-analysis, we showed that choline-fed cows had a reduced incidence of mastitis and retained placenta. But what Pete Hansen from University of Florida, he showed that when choline was supplemented during the time of the breeding of the cows, they basically had more risk of pregnancy, and also the calves which were born from the choline supplemented cows, they performed better in terms of the morbidity point of view. So yeah, short answer is, I think choline is very much required nutrient during the transition period. Methionine is also very much essential amino acid to support the production performance. Depending upon the goal of the farmer and economics, how much he wants to go ahead with that, I think that decision can be taken accordingly.
I can add one thing on that. There are studies done in Wisconsin University with Heather White that you know pretty well, that basically showed no impact of methionine on fatty acid export. How do you say that? Export. While there is a specific role of choline on that factor. So I agree completely. These are two very valuable nutrients for dairy cow that have different role. So the best for me, and what I typically propose to customers, to farmers, is to use both of them. Because as we showed today during my presentation, it's true, it's a cost, but the value and the return on investment that you can have from feeding both of these ingredients can be higher than just feeding one.
Great answers, guys, and a great question. If I can just comment, absolutely, choline and methionine are required nutrients for the transition dairy cow. And in all the studies that Balchem have done, at least in the last 10 years, have been with choline, have been done with the required level of methionine. We are not doing studies with low levels of methionine. We are doing it with supplemented room-protected methionine there and showing the sort of responses. Usman's meta-analyses showed 2.2 kilos more milk. So, the response is there. I would also point out, when people talk about methyl donors, methionine is a single methyl donor. Choline has 3 methyl donors. But to me, they are both essential nutrients. They both have separate roles within the body. And why would a transition dairy cow use choline to make methionine when it's essential, or use methionine to make choline? That does not make sense to the cow. She's under pressure. You've seen with some of the presentations today the potential to lift and increase performance. And the only way you will do that is to supply the essential nutrients. And that comes from supplementing choline and methionine. And we know if you get more milk yield in early lactation, you get more milk yield at peak. When you get more milk yield at peak, you get more lactation yield. So that is critical.
Yeah. I guess one aspect of the question was also the dose on the choline, because he wanted to ask if 13 grams choline ion is enough or we should go for more. If you ask me, do we really know the dose of choline? It's a very interesting question. And we have spent so much money and resources to identify the dose. So when we did meta-analysis across 21 experiments, which was done in 2020, and now after that meta-analysis in last 5 years, we have 7, 8 other experiments coming from Barry Bradford lab, Heather White's lab, even Jose lab. So we always found a linear relationship. So as you are feeding more choline ion, you are getting more milk. But majority, 70% of the experiments, they have been done using 12 grams of choline ion. So that's why we suggest that we recommend that at least cows should receive minimum 12 grams or 13 grams of choline ion. And when we tried choline ion supplementation in dry cows, so we did 2 independent experiments, and in each experiment we had 100 cows. And we induced fatty liver in those 100 cows each time. They were supposed to eat, let's say, 15 or 20 kilograms on dry matter basis. We only supplemented them with or provided 5 kilograms because we really wanted them to develop fatty liver. And they did. And when we supplemented them with choline ion, and we had several levels of choline ion, we had 0, 12, 18, 25, until the 25, we observed a linear reduction in triglycerides level in the hepatic tissue. So if you ask me what is the relationship between choline ion and productive performance or liver triglyceride removal and choline, it's a linear relationship. So probably we will get even more benefit if we supplement more. But if you really ask me, do we have enough evidence, do we have enough experiments beyond 13 grams of choline ion or milk production performance, we really don't have many experiments. Only 2 experiments. One was done in 2008 by Alec, and one was done, I don't know, in 2014 somewhere in China, who supplemented 18 or 25 grams of choline ion. And both experiments showed an increase in milk production. But we don't have much experiments at higher dose.
Thank you.
So can I pile on one more time?
Sure.
So to that point, I've been trying for several years to convince a few people to sponsor a postdoc to figure out these requirements, because it's obvious that the cow has a requirement for choline, and I'd like to just estimate the requirement and put it into the nutrition model so we stop guessing
Yep.
what the right number is, right? So that's the next trick. So that is kind of high on our to-do list because it's obvious that the cows are responding positively to choline supplementation. So it's back to that idea: is it required, non-essential, essential? Doesn't really matter. We see a response. Can we quantify how many grams of ion we need to make that happen?
Yep.
Right. Just to add to that question, right? And we didn't get to this data. Coming back to the amino acids. You know, in the studies from Ohio State and from Cornell, where we increased the metabolizable protein and the amino acids pre-fresh and in the fresh pen, we haven't done it with and without choline, but my intuition tells me if you put it all together, you're going to get an additive effect, right? So where we saw, 7 kilos of energy-corrected milk by pre-fresh, fresh, enhanced feeding of MP and amino acids, if we layered choline on there, I'm going to guess we're going to get another level of response, right?
Yeah.
And that's the kind of work that I really want to see done somewhere. That's probably not what I'm going to do. Maybe you can do that.
But I think it's very interesting to see this kind of discussion when it comes to the identification of requirement. So let's take an example of vitamin D. Is vitamin D a required nutrient in Arizona?
No.
Is vitamin D a required nutrient in Norway?
Yes.
Yes. So I don't know when it comes to, and we really fight. I mean, when I published my literature review in Journal of Dairy Science on choline, we had to really fight with the reviewers, and we wanted to have our title, choline, a required nutrient in dairy cows. And we got a massive loads and loads of going back and forth, and they were saying, oh, there will be legal issues and this and that, and they really made us to change the title. So I don't know what was the really...
I'm sorry I didn't get to review that paper. I would have fixed that for you.
But I am a strong believer that if a nutrient is responding in terms of cow is improving its health, production, performance, and lots of literature has shown that after transition period, in the transition period, like right after calving, you see a major dip in the phospholipids. You see phosphatidylcholine, sphingolipids, they all go down. And all of them have role in the synthesis of membranes, and cow needs those membranes. She has to use those membranes for the synthesis of mammary epithelial cells, for the regeneration of the uterine tissue, lots of things. So I think choline should be a required nutrient. I'm a strong believer on that.
And relative question from me, relative to amino acid balancing in the close-up, we are quite precise on the knowledge we have on lactating cows. Maybe, Mike, you can share some data relative to requirements for the last phase of dry cows, and perhaps an indication relative to one group TMR for dry cows.
Sure. The one group TMR thing is harder, but I'll just address the pre-fresh. So in a lot of if I think about the studies that were done at Ohio State and Cornell, they would have been somewhere between 1,100 and 1,200 grams of metabolizable protein in the pre-fresh group. Mm-hmm. We were running 1,600 to 1,800 grams of MP, right? It's a lot.
Crazy.
Yep. It sounds crazy. But again, so let's disassemble that a little bit. We're talking about metabolizable protein. So if we go back, I made the comment about non-essential amino acids, right? And I didn't have enough time to show all this, but there was a paper published a few years ago, so this is going to come back to all this. There was a paper published a few years ago where they challenged the idea of essential versus total amino acids in a fresh cow. And they did this by infusion on 50 cows, right? They infused all essential amino acids, or they infused all amino acids, right? The difference in milk production was 9 kilograms, right, in those cows. So that clearly said the non-essential amino acids are playing a role in energy synthesis, in protein synthesis, and all that stuff. So that leads us to say, okay, we can target the methionine, the lysine, the histidine, and all these things, but for that cow pre-fresh and fresh, she needs all those non-essentials and more of them to be able to fill all those pathways to synthesize more glucose and do all the other things that she's doing. And that's where we pick up the milk effect, right? Yep. We need to figure out how to do that more routinely, you know. But in the Ohio State studies, in the Cornell studies, you're looking at 5 to 8 kilos of energy-corrected milk, right? It's a significant response, right? And then if you were to ride that all the way up to peak, man, that's a heck of a response over the lactation. So I think we have to change our perspective on how we balance those pre-fresh and fresh cows. But that also means, you know, you don't stop supplementing, right? In the fresh cow pen, you have to keep it up because you've now changed the shape of the curve. Your requirements went up. You got to follow that all the rest of the way now. Now, on a single group thing, I don't know. I guess we have to go back and do the research. That's a lot of protein to feed a far-off dry cow.
Yeah.
Right? So I think we have to figure that out.
Yeah.
If I can just come in, you know, we're here on a Real Science podcast. I think last week was a great Real Science webinar by Dr. Phil Cardozo, exactly on the question. But, you know, I think in that webinar, Dr. Cardozo talked about the pre-fresh or close-up dry cow requiring 35 grams of methionine and 100 grams of lysine. And, you know, showing his group, some of the publications, show very significant responses in terms of milk yields from doing that. I think it's you know, in Mike's presentations, he talks about grams per megacal, and I think the numbers are fairly similar for the transition cow, but I get a little nervous by using those. I feel more comfortable using the absolute gram of requirements. But I would totally agree with Mike that you've also got to look at the total amino acid balance. And I think Dr. Cardozo talked about minimum 1,200 grams of MP. You know, I think, you know, some of the Cornell work suggests going a little higher. But, you know, it is, you've got to meet MP, but you've got to meet those 35 grams of methionine and close to 100 grams of lysine.
Yeah, the numbers that end up coming out of Phil's data are like 1.24 grams of methionine per mcal and about 3.2 or 3.4 grams of lysine.
Yep.
Right. So it's actually higher than what we talk about in lactation, but that's where you see in the responses.
You can find that webinar at balchem.com/realscience. Had to get that.
It's our public service announcement.
From our sponsors. All right, we have a question down here real quick.
Okay, couple of questions about the model. Before you finish your wine.
He might need some more wine.
What I'm afraid of.
Okay, the first is related to the amino acid profile of the rumen and degradable protein. The model assumes that the profile is the same than the original feed, the feed offered to the cows. Is that biologically true, or is it rather a shortcut to avoid some more complications?
Yeah, I can answer that. No, we've challenged that, Romano. We've got our own in-house data. We never fully published it. We actually started with intact feed, took out the soluble portion, reran the amino acids, ran an NDF, ran an ADF, ran a lignin. And you're right, it's different all the way down. The question is what does it look like on the digestible portion of the feed? Because we call that lignin fraction, right, after you've hit it with 72% sulfuric acid, you think you're looking at lignin. I will tell you there's a lot of amino acids in there because it's all incorporated in the structure of the plant, but they're never going to be available. So there's lots of interactions going on there. Here's my take home. Everything I showed you this morning is as we currently have it. I can balance all those amino acids to very, very fine requirements using the feed chemistry as it currently exists, which tells me we can do work to say it looks different, but the cow doesn't seem to recognize that, right? So I think we're okay for right now, right? It goes back to the same question about the forages and the forage chemistry. You know, Dairyland Labs is publishing a bunch of data right now that says, hey, depending on the fermentation, you're going to see a change in the amino acids, right? That may be true, but we don't see that behavior when we're formulating all these diets. So I think there's 2 or 3 things going on. Maybe depending upon how the fermentation behaves, how fast we get to a pH of 4, maybe we break some cell walls, we get some cell solubles that are released. That becomes, you know, maybe some ammonia and some soluble true protein. The cow consumes that, but now that soluble true protein is in the liquid phase and it passes 4 times faster than the solids. So that we already know that is delivered to the small intestine as metabolizable protein at about 15 to 20% of that pool, right? And we're capturing that. So I think the way the model's currently set up, depending upon if it's in the soluble, insoluble pool, we can predict that flow, right? Is it ever going to be 100% correct? Absolutely not, but it's useful right now, right? We haven't found a boundary where it's not useful.
But basically, we do not have any way right now to fix this issue or this possible issue.
No, we do. We know how to do the chemistry.
The commercial labs have some procedure?
Well, we know how to do it in-house. We could teach them. I don't think it matters because I can balance these diets to extraordinary levels of productivity, and I don't need all that information.
Okay.
If I can just come in, I'm aware of 2 European data sets that have exactly set out to answer that question, and particularly one to do with the new German feeding system. They actually set out with the hypothesis that amino acid flow to the small intestine was not the amino acid composition of the raw material, and the publication actually disproved it. But the publication proved that the amino acid profile of the raw materials was not significantly different reaching the small intestine. And there is a similar data set coming out of Wageningen, which I don't think is published, but I have seen the data, and it says raw material profile is the same once you've reached digestible. So, you know, it may be an issue, but I don't believe it is the current issue that is preventing us seeing responses to amino acids. You know, and that is critical. You know, we've got to move the game forward to unlock the potential of these dairy cows.
Okay, the second question is related to the first one, and it concerns the protein degradation rates.
Mm-hmm.
The current value seems to be quite out of date because they are coming from the original feed library. We changed something with the new version, okay, but we do not have any way to adjust the degradation rates like we are doing for carbohydrates. So
yep.
Is that a concern?
I'm going to sound a little bit like a broken record, and then I can get down on my knees and beg. So there's 2 functions there. Again, I'm gonna go back to what I said a few minutes ago. Right now, the way the model is set up, despite the fact we can't do that, we're getting very good responses to all of this amino acid balancing, which says, despite the fact that we don't know the degradation rate of every protein pool that goes into that thing, on average, we're sensitive to the deficiencies or excesses of particular amino acids. Again, does that mean it's accurate or precise, right? It might be accurate, but it's not precise. But that's okay as long as it's sensitive because it's still useful. Here's the problem, Romano. I can't find anybody on the planet that will pay for a postdoc and the research it's going to take for me to improve that.
I understand.
So right now, if we can balance the amino acids and we see the cow responses, then I don't have the time to go question that because it's not impeding our ability to use the model.
So it is possible that we are getting good answers through wrong ways.
Absolutely. Every model behaves that way. Every model behaves that way. I don't care if you're talking about INRA, NASEM, ARC, feed into milk, they all have their biases. As long as they're internally consistent and you know your assumptions, they're all going to work. The INRA model, I met with them a year ago. They wanted me to help them build a branched chain amino acid or fatty acid submodel. They underpredict microbial yield by 30% and overpredict RUP by 30%. I said, are you going to fix the microbial yield function because that's the demand function for the branched chains? They said, no. I said, good. Let's go drink some wine, right? Because I can't help them. But I think that's the point, is that we all have some biases. But we've worked so hard to get to version 7 where we know we can balance for all 10 essential amino acids without having to estimate all those protein pools. Do we want to? Do we know that's a weakness? Absolutely. But somebody please tell me, where the hell am I going to get the money and the people to help me work it out? Does that mean we throw the model out because we can't do that? Sorry, you're getting my irritation here because I have to work so hard to get the money to make this damn thing work.
Do you want this money from me?
No, I'm not asking you for that money. But I think that's the point, is that...
Wrong answer. You should say yes.
I should say yes. He already, by licensing, he already gives Cornell a lot of money. We don't see much of it, but he gives Cornell a lot of money. So that's credit to him, right? So I'm not going to take that away, and that doesn't mean I want to double dip, right? But I do think, in reality, that's a problem with all of these things because it's an iterative process, and we know we have that on our to-do list. But nobody seems to be interested in that, right? Because it doesn't serve anybody's personal interest, except for people like you and me who say this is probably a weakness in the model.
If I can come in, Mike.
Sorry for the question.
No, don't be sorry, Romano. But I think, it is one of those things, what can we get done? Who's going to pay for it? And who benefits from it, right? We would all benefit from it. And that's the problem. Everybody benefits from them. Nobody sees it as I can make more money off of that, right? So it's not a priority to them.
If I can just add, I come from the UK with feed into milk. And feed into milk has the ability to change the degradation rates of protein. And when they built the feed into milk database, it was good.
Where they go?
But nobody can measure the degradability rates of those raw materials. So as raw materials have changed in the 25 years or whatever it is since the feed into milk database has changed, actually, I would trust CNCPS numbers more than I would trust feed into milk numbers from a nitrogen flow, a microbial protein, and an MP. So to me, though feed into milk has the ability to change the degradation rates, it actually, no one has the ability to measure it in a commercial laboratory. So even if Mike, adds it to the model, who's going to measure it in the laboratories?
But that's the point. We have the rates in there.
Yep.
Right? We have the ability to change it.
Yep.
I got to figure out how to build the assay that allows us to do it, and the only way we know how to do that is with N15, right? Because we have to mark we have to have a marker in there to understand which protein's coming off, where it's going, who's using it, what's remaining. You know, we could do it and come up with an assay that's fairly robust, but that's going to be at least 2 years of research and a whole lot of money to do a whole lot of very detailed protein stuff. We've got a mass spec, we've got the equipment, we're good to go. It's just building the assay. Next question.
Mike, I
didn't
expect to get a language rating after this episode, but I think we're going to get one.
No, I don't think so.
Hello. For choline and methionine, what's the efficacy of choline and methionine in transition period and colostrum quality? Did I see in my farm when I'm using this both with each other, I see the colostrum bricks increase from 22 until 28. So what's the efficacy for this?
So that's an interesting finding. So recently, from Michigan State University, Barry Bradford Lab, they did this research on colostrum. So they did feed choline during the transition period. And interestingly, they found that cows fed with choline, they produced a lot more colostrum than those cows which were not supplemented with choline. So, which tells me that choline has a role, especially during the transition period in the mammary gland, because in the mammary gland before calving, the mammary gland is going over the recovery phase. There is repair, wear and tear is going on. New cells, old cells are dying, new cells are generating. And from the cancer research, if you see the role of choline kinase enzyme, it's like a cancerous role. It's like a mitotic role. So it helps to increase the number of cells. So probably when you are feeding choline during the transition period, when there is wear and tear going on, so at that time, choline is supporting the role of mitotic activity there, ultimately resulting in more mammary epithelial cells, which tends to get into more colostrum. So yes, so in terms of enhancing the efficiency of the colostrum and the immunoglobulin levels, yes, choline has a role there. Now, does it help in terms of the calf's performance? There is not much data, but whatsoever experiments we have so far, they suggest that calves who were born from the cows who were fed with choline and also received the colostrum from the choline feeding based mothers, so they had more immune resilience. So we did this experiment at the University of Florida where we fed choline to the cows in the transition period, and then we used that colostrum to feed cows with or without choline, like a 2x2 factorial arrangements. And then we did LPS challenge. So we injected bacteria into the blood vessel of the calves just to see how they respond. And guess what? Calves who were coming from choline-fed cows and received also colostrum, they were more resilient, so their immune response was better compared to the other calves. So, and they also had a less risk of morbidity. So when it gets to the efficiency from the methionine and choline perspective, I think they both have roles in improving the performance, and depending upon what is the stage of lactation and what nutrient is required most at the time, both nutrients will be much more effective at the place.
My question for Dr. Mike, for amino acid balance for the cow for under heat stress, is the same using the standard same as another in cold weather or non-heat stress?
Yeah, to the best of our knowledge, we would just maintain it. You know, there's some evidence that amino acids will, I don't like using this word, will protect against heat stress a little bit. I don't think that's the right way to think about it, but probably because it makes metabolism more efficient, there's less heat production, wasted heat production, right? Back to my conveyor belt analogy. So I think in that situation, that probably is somewhat protective against heat stress, and there's some data that would support that. Not enough yet, right? Because again, Joe McFadden challenged that a little bit. with some methionine and leaky gut and heat stress and found like, a 3 kilo milk response, right? I think he could have found a larger milk response had he also met the histidine and lysine requirements, right? He only targeted one amino acid in that heat stress study. But I think there's things like that out there where, now all of a sudden, if you start going through the whole pathway, what's going on in the cow, and we talk about leaky gut, well, if you can offset that by making sure that there's enough amino acids there for protein synthesis, I think that's good. For immune response, that's good. To fight the inflammation, that's all good. I do worry about the microbes. The one thing that I do worry about that I'm not sure how we're going to solve yet is that the microbes actually have a thermal neutral zone, right? So when the cow core body temperature is increasing, those microbes are responding accordingly. And I think one of the things that I get concerned about is they're producing less butyrate, and now that precipitates all those cells, those enterocytes, to slow down their metabolic rate because they don't have enough energy, and that then creates a condition where they start to shrink a little bit, and now we get those channels, right? So maybe the amino acids, and maybe it's even the non-essential amino acids, may be important in that role as an energy source, right? So there's a few different ways to think about that, but overall, the quick answer is it looks like those meeting the amino acid requirements will help those cows through that period.
For suckling heifer, also the amino acid, the essential or non-essential. You have any research for this now?
Not directly. You can see it in the literature if you read hard enough, right? This is where we have to, I think this is where the modeling effort is really interesting, right? Because it allows you to frame, you can run things through the model, you can see a certain response, and you can say, okay, this looks interesting because I see this response where these guys get this and we didn't. So there's different ways of looking at it. We've got to do more work.
Bianchessi, a farmer. I have a question. Not very scientific, but related to economics. The data that were presented told us that we have to use much more lysine and methionine versus what we are using and vis-a-vis what our cows are eating. But to reach those levels, we have to find a source, which could be that from Balchem, of course. AminoSure LX when it will arrive. But I made two calculations based on the products that I'm using already today. I think that the price will be along that range. And as Vandoni was saying this morning, for 100 grams of XL, of AminoSure XL, we would go to 34 grams of lysine in the bowel. But 100 grams of this, it's almost a liter of milk. So if you make your calculations, it corresponds to a liter of milk.
Yeah, I'm going to do two things. Maro, I think the question, your question's good. I think the question comes down to how are you paid for milk? And are you going to be rewarded for, I showed those increases in components. Yeah, and I'd have to look at your diet, but it's probably going to be, yeah, it's going to be significant. Your 100-gram number is probably not unrealistic in reality. Right. So, but again, when I look at the farms in New York, right, we took a lot of those herds. I showed you two diets. I showed you two herds. I could show you a bunch more. Our fat was running roughly 4.2, maybe 4.3 in a bunch of those herds. The moment that we increased, methionine, lysine, histidine, all of a sudden we found those fats up at 4.6 to 5, right? And the proteins all followed. So if that's true, and we see it to be true because every time we do it, and we've got good forages and they're actually delivering that, those are significant increases in components, no change in dry matter intake, right? In almost every system I know, that's got a financial benefit, right? And the return on investment is in most cases, at least 2 to 1, if not more, right? So in dairy, that's not too bad. So that's what I see happening, right? We would have to sit down with a bunch of diets here, figure out what the supplementation rate looks like and what the expected outcome might be, and then kind of figure out relative to your market what that return on investment is going to be.
Well, I mean, what I can add, if you look at the diet that I present today, the diet for Grana Padano with corn, based on corn silage, our diet are much more, need much more methionine than lysine in terms of lac. So should you use 100 grams? I'm not sure. Maybe Mario, you can give an input on how much you're using AminoSure now.
Yeah,
that it's less concentrated, but you can have an overview of how much in general you're feeding of lysine.
Well, to be honest, as you said, we first start with methionine, which is the first limiting, and then in some cases there is also the need for lysine, and I'm currently using it in high-producing cows. So before peak and until peak, or high producing 1 group TMR, and the dosage is, let's say, roughly from 30 to 60 grams per head per day.
And this is the less concentrated, so that means that you're feeding a more concentrated product. You probably will be in the range of 30 to 45 to 50. Of course, I mean, at the end, what matters is the return of investment in your farm, so at your home, and see if that gives you a return of investment in terms of milk, constituents, because that's what matters.
Stefano, our studio audience has heard of XL because you gave a presentation today, but our other audience out there has not. Would you mind kind of giving us a real quick overview as what is AminoSure XL?
So AminoSure XL is the new generation of our rumen-protected lysine. Will be launched in early next year here in Europe. Has been launched already last year in November in US. It's more concentrated, so from an economic point of view, it's more convenient than our actual AminoSure L. Technology-wise, they're very similar, so the bioavailability of the product is exactly identical. But being higher in concentration of lysine, you have more metabolizable lysine out of the same amount of product, basically.
Yeah. All right, good. Dr. Arshad, you've not had a chance yet to talk about the presentation you gave. Talked about a lot of other things, but real quick, can you kind of give us kind of some of the key takeaways from your presentation that the audience ought to take with them?
Yeah, the idea was to review the literature and come up with a quantitative answer, what happens when you supplement rumen-protected lysine or you don't. And we did some literature review from whatsoever is published from last 30, 35 years. And we come up to the conclusion that if you include rumen-protected lysine, you start early in the lactation and you keep going, we get to have almost 1.5 to 1.75 increase in kilograms increase in milk yield. Another aspect was to see how the intestinal, how the concentration of lysine as a percent of methionine, metabolizable protein is linked to methionine in terms of feed efficiency. So which we did some analysis, and back to the data which I showed, both amino acids, lysine and methionine requirements needed to be met in terms of achieving full potential from the cow.
All right, very good. Mike, one question I wanted to get to, you and I are having a conversation last night. We were talking about rumen-protected products. You've developed a methodology that you can evaluate rumen-protected products, and I think the reality is they're not all created equal. And so would you mind kind of talking us through some of that?
Anonymously?
Yeah. No names, but
no names.
What are some of the things you found?
Yeah. Protection systems are interesting. Everybody's using things from, lipids to polymers to combinations. I won't name everything. Yeah, Scott, there's probably not for the most part, there's not a rumen-protected amino acid in the marketplace that we haven't analyzed whether we wanted to or not. Sometimes it's anonymous, right? People send us amino acids. We have no idea who they're from. We analyze them. We give them back the data. I have no idea what they're going to do with it. We didn't even know what the product was, right? But I can tell you, here's the range on our data. We go from roughly 80% efficiency to 10%, right? It's big,
Yeah.
right? But what I tell everybody, personally, I don't care, right? You know, and Hermano wouldn't care either, as long as you told us what it was and you priced it accordingly. Hey, if it's 10%, great. I know I have to add X amount to get Y outcome. Just price it accordingly and let's go. I think that's my biggest frustration. You guys did a brilliant job here because you put up on the slide, this is our efficiency. And I wish others would do that and be completely transparent, because that's really where we're falling down, right? When you put that 64% efficiency up there for your lysine product, brilliant. Because now we can load it up in the model, we can set it up and say, hey, if I feed 100 grams, I got 64 grams going to the small intestine. Go, right? And that's one of my frustrations. It's the same thing Hermano brings up about the protein rates. I mean, he's right? And I know he's right. Again, there's from the tension you saw in me is like, who's going to pay for all of that work, right? And I'm so tired of begging for money. But the point is the same thing on the amino acids, right? We know what it is, but we're not going to hold the companies accountable. We're going to make them tell us, what does this look like, right? So you just need to be honest and move forward, and that way we know the amino acid's going to work. I think that's one of the problems, is when somebody says, I tried amino acids and they didn't work. Okay, did you know anything about the bioavailability? And most of the time, Scott, they'll look at me and say, nope. No, I don't know. What is that? Yeah. Right? And that's the first step.
Yeah, if I can add one point that is related to the question before about cost as well. I mean, I think the effort of a company as Balchem is to find a solution that will provide more and a more economic cost for producers. Because if we are more economic, basically you can sell more. So it's our interest as well to produce something that is more viable for you. The problem is that, as I was mentioned before, developing these products has a cost. I mean, we started 2015 to develop the AminoSure XL. It's 10 years of work. It's nothing. I mean, it's 10 years that a company invested time, money, research to develop something. So the cost per se of these products is not just the cost of the lysine and the fat that is used to do the product. It's all the things that are behind this product that make the cost. And of course, by developing better technologies, better core, better encapsulation technology, we will be more convenient. I mean, you can see AminoSure XL will be more convenient than L, even for a farmer. So it's an improvement. So I believe, I perfectly agree, and I mentioned during my presentation, look at reliable numbers. With amino acid, it's very easy because you just can calculate what's the cost of the unit of metabolizable methionine or metabolizable lysine of product. But it has to be proven by reliable data. That's just what I want to pass as a message I was trying to pass during my presentation.
And reliable data that is published. You know, Balchem's numbers are all published in scientific publications, and some competitors have a similar approach, but many of our competitors don't, and their numbers just come from there. And that, to me, frustrates me, that when you see great science from the gentleman to my right, and then people feed a room-protected amino acid that is very, very poorly characterized, and it doesn't work. And that discredits the whole industry. And we've got to be credible in our approach and use sound, published methods to measure bioavailability.
Yeah, thank you, Sean. Kind of at the top of the hour now. It's kind of the quitting time, but I wanted to make sure that there's no really burning questions out there that you just have to ask before we close up shop here. Any big questions out there? We do have.
Two at the front.
Now all the hands rise up.
Bring another round.
Yeah, more wine.
More wine, another hour, Scott.
Balchem has invested decades perfecting the art of nutrient encapsulation. And now, new AminoSure XL is setting a new standard, delivering 35% more metabolizable lysine than leading competitors. With AminoSure XL, you can provide your cows with a more consistent and higher quality source of metabolizable lysine, leading to improved and more dependable results. A recent meta-analysis found that feeding rumen-protected lysine led to an increase in milk fat percentage and 4.4 more pounds of energy-corrected milk. Feed new AminoSure XL to your cows and have confidence that you're using the most consistent, reliable, and cost-effective source of lysine on the market today. Learn more at balchem.com/XL.
Yeah, thank you very much. My question is that regarding the bioavailability of the amino acids, which technique is most reliable? And because I have listened many techniques, some are using blood plasma dose response, some are using selenomethionine, some are using isotope technique, and some are using in situ nylon bag technique. So in which technique you recommend this to check the bioavailability of the rumen protected amino acids? And my second question is that to Dr. Usman, if my animal BCS is okay, and the animal is not fatty liver, so what is the requirement of the choline?
Okay. Let's do the second question first.
Sure. So I think the question is, if the BCS of the animal, you're talking about prepartum? So if the BCS of the animal in the prepartum group is not obese, let's say it's not 4, should I still feed my cows with choline? Because I think there is a dogma here which makes the point that if the cows are having more BCS in prepartum group, they tend to have more risk of fatty liver in the postpartum period. So basically we conducted 2 experiments to answer this question, and that work is published in Journal of Dairy Science as well. So we had 220 dairy cows, and those 2 cows, half of them were fed with choline and half of them were not fed with choline. And then we had a distribution of body condition score in the prepartum group. So we had cows which were very skinny, having BCS 2.75 or 3, and we have also very obese cows which has BCS 4.25, 4.5 in the prepartum group. And when we did this statistical analysis, we did not find any interaction between choline and BCS, which makes the point that irrespective of the BCS in the prepartum condition, cows who were skinny or cows who were obese, they both had an increase of 2 kilograms of milk in the postpartum period. So I guess, yes, choline has lipotropic role, but besides its lipotropic role, it has some other roles as well which supports the animal performance.
So I'll take a stab at the bioavailability. So here's what I know. We have an in vitro, we don't use in situ bags because you lose everything. So we have an in vitro method that we've developed that includes undigested nitrogen. When we apply that, and we do it in-house, a commercial lab's still not quite precise enough. To Romano's point, can a commercial lab do this? Sometimes yes, sometimes no. The problem with nitrogen that I've learned, Romano, is they're just not good enough at knowing where the nitrogen's moving through the system, and they lose some, and then their calculations look terrible. So if you run the assay correctly, we have compared it to the isotope dilution and to the dose method, UNH, things like that. We can come within decimal points of each other if you have good data in the same product. The selenomethionine in the hands of Bill Weiss and Norman St. Pierre and maybe one other group is incredibly precise. Some other groups have tried to replicate it. You got to talk to Bill Weiss. It's a very particular selenium methionine product. And there's a couple particularities about how they run it that's inherent to the assay. As long as you use their true protocol, you can replicate it. If you deviate from that, I think you have it. That's not to take away from the assay. The assay is good. These guys have used it in some of their products, and we can replicate that too, right? So I don't think it matters as long as you understand the conditions and the assumptions in each of the approaches. How's that? So I never get into that debate. Again, it's like the conversation that Hermano stimulated. Every one of these things has its own assumptions. As long as you understand that and you know what the data are supposed to look like, you can get a pretty good answer, right? So I think we're okay.
Last question right here.
Thank you. So there's a trend on the dairies nowadays in Saudi to use less monensin or to ditch monensin altogether. The reasoning behind it is that we're using too much grain, too much propionic acid already being produced that we might not need the monensin. So what are your thoughts on that? And you had one slide when you had the correct use of amino acids and then monensin was used, and there was not much milk, I guess, response. So yeah, with today's, I guess, production, what are your thoughts still on monensin? And when we formulate for amino acids, do we still need monensin in the rations?
Yeah, almost all those studies that we showed have rumensin in there. So let's back up a step. So so in the study that I did show, what was interesting though is that the rumensin, if you stick to what it's supposed to do in the rumen, right, it's going to shift your fermentation towards propionate because you need a hydrogen sink because you shut down some of your methanogen production. All right, the old data used to show that intake effect. I don't believe that to be true. Those were diets, and those were 20 years ago. If you look at all the contemporary data, the intake does not change with rumensin, right? But we do pick up an efficiency. And one of the things, as I showed there in that study, and we've seen this in 2 studies now, we see this effect of the rumensin on the de novo and the mixed. So that fits with the idea that it's shifting the fermentation. They're producing more propionate, they're getting more glucose, which then allows for that extension, right? Because that energy is all needed to do that extension. So I think there's a benefit to feeding it. You posed it in a different way. You're talking about so much concentrate. And this has nothing to do with rumensin, but this is something that I've noticed in the field studies that we're doing right now in New York. I think we're feeding less and less NDF and more starch. And I truly believe this is Mike Allen's hot theory coming back to haunt us. Right?
Not Mike Allen coming back to haunt.
Not Mike Allen. And I was told, Mike, don't call it a theory anymore because we know it works, right? But anyhow, but I do think we're probably at the point where we're making a lot of propionate. Because what we just did in one of our studies is I'm trying to figure out how to get rid of the nitrogen. I'm using version 7, right? We're making all these changes, but I pull out some of the protein sources. I put in a little more forage, and I lose intake. And we're only at 27% NDF. And I do it in another herd, and I see the same thing, right? And we do it in another herd, and we see the same thing. And all these nutritionists have told me for years, Mike, we can never feed more NDF because every time we do, we lose intake. Well, I know if you follow Dave Merton's numbers, all of those diets would be 32 to 35% NDF if we follow Dave Merton's numbers, and we're down at 27, making very subtle changes and losing intake. The only thing that I can come up, because we're also 29 to 31% starch. Sound familiar? Yeah, I know. So I think they're making so much propionate that very subtle changes in NDF are just, we're hitting some threshold around that propionate fill effect. It's chemical fill. But it just, those minor things cause this this big shift in intake that makes absolutely no sense except for there's too much propionate, right? So I don't think it's about the rumensin, I think it's about the propionate in general. But they say you can't feed more NDF. Well, I showed you our diets, right? And I didn't show you a particular study where we started earlier in lactation, did the amino acid thing. We were running 32, 33% NDF diets, 26% starch, and we had the same or higher intakes, and we never dropped below 52 kilos of milk. So I'm wondering, have we evolved to these starch levels and these NDF levels because we just don't have the inventory on the forage, right? So we're stuck feeding all this concentrate because we don't have the forage. So we've created our own condition where we don't like it because we're not seeing these increases in intake, right? Because in our own hands, when we feed 32, 33% NDF, we still see 27, 28, 29 kilos of intake, and it's higher intake than these guys are showing in the field. So that to me says it's Mike Allen's theory, visiting our dairies every day because we're just trying to get too much starch in there. We've got to figure out how to get more NDF in there from the get-go and then pull back, then titrate in the starch. And if you look at the recommendations I have on the slides, I'm recommending 26, no more than 27% starch. And that sounds antithetical to all of my colleagues in New York. But every time they get close to that, we get better efficiencies. We see more energy-corrected milk, right? So but there's a research project if there ever was one, right? Because Mike always worked at the boundaries, not during established lactation. Yeah.
All right. Well, I think we've got another session to get to, right, Stefano?
Yep.
All right. Very well. We can continue this tonight. I think we're all going to dinner tonight, so we'll continue it there. Listen, guys, this has been an interesting one.
Yep.
And I appreciate it. It's been a lot of fun. To our studio audience, you guys have been great. Great questions. Thank you for joining us. To our loyal listeners out there, thank you for joining us once again. We hope you learned something. I hope you had as much fun as I did. And I hope to see you next time here at Real Science Exchange, where it's always happy hour and you're always among friends. All right.